Okay, so where we left off on the last video was that we were working on question 23, and it turned out that it didn't work. We couldn't factor it, not a times c factoring, so there was just nothing we could do. So we decided that it would be a great idea to use the quadratic formula, because the quadratic formula will get us the roots. So what we did was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, we want to plug in. So the values that we're plugging in are 2, negative 6, and negative 19. So here's what we're going to do. X equals negative b plus or minus the square root of b squared, negative 6 squared, minus 4 times a times c. All of that over 2a, which is 2 times 2, which I'll just write as 4. Now this underneath the radical, this is called the discriminant. It's right here. I'm going to do that in my calculator in one move, so I can figure out what the heck is going to go under that square root. So let's see. We're talking negative 6 squared minus 4 times 2 times negative 19. 188. Okay, 188 is going to go into there. So I've got that x is equal to 6 plus or minus the square root of 188 over 4. We want to see if any perfect squares go into 188. So we're going to see, is 188 divisible by 4? It is. Is 188 divisible by anything larger than that? I don't think it is. 47 does not have any factors. No. Okay. So here's what we're going to do. We're going to take this rad 188. I'm going to do a little magic on it. 188. So square root of 188 is the square root of 4 times 47. 4 is equal to 2 squared, so 2 squared times 47, and it can give up its exponent and come on out, and it's not under there anymore. So I get 2 rad 47. Now I'm going to plug that back in. X is equal to 6 plus or minus 2 rad 47 over 4. And all of these terms can be divided by 2, 6, 2, and 4, so I'm divide them all by 2. So x equals 2 over 2 over 2, 3 plus or minus the square root 47, because 2 over 2 is 1, so it goes away. 4 over 2 is 2. And those are the roots of that equation. Solve for the sum. In order to add them, right, sums, they have to be like. They're not right now, so here's what we're going to do. This is going to become 4 and 3. 4 becomes 2 squared, so 2 squared times 3, and the 2 can come out, so we get 2 radical 3. On the right-hand side, 2 rad 75, this is going to become 25 times 3. The 2 hangs out on front. 25 becomes 5 squared, so we get 5 squared times 3. 2 still on front. Let me put it over here. And the 5 can give up its square to come on out. 5 times 2 is 10, and the 3 is stuck underneath. And they want us to add them. 2 rad 3 plus 10 rad 3, 12 rad 3. 25, 240 into radian measure. Great. So 240 over 1, and we want to times this by 180, pi on top. I know that I've got the right setup because the degrees will cross out. That's going to get me 240 pi over 180. And I'm going to want to use the calculator to simplify 240 over 180. I could divide them by common factors, but this is just easier. 240 divided by 180. Math, enter, enter. 4/3. So my final answer is 4 pi over 3. All right. 26. Solve this by completing the square. Completing the square requires me to do the following. Start off with a regular equation. X squared plus 8x minus 8 equals 0. These terms are a, which is 1, right? B and c. What we do first is we move the c term over. So that's plus 8 plus 8. When we rewrite it, we're going to leave a space. X squared plus 8x equals 8. Now I'm going to take the b term over to the sidebar. B is 8. So I'm going to take the 8. I'm going to do two things to it. I'm going to divide it by 2. That gets me 4. And then I'm going to square it. 4 squared equals 16. Now this 4, right, the result of division, I always call the important number, I. This 16 is going to get added back into both sides. Plus 16 plus 16. The reason why is because if you think about this, what adds to 8 and multiplies to 16 is 4 and 4. So this becomes x plus 4. X plus 4 is equal to 24. X plus 4, that's the same thing as saying x plus 4 squared equals 24. I want to solve for x, so I'm going to get rid of the square with a square root. So that tells me x plus 4 is equal to plus or minus the square root of 24. X is almost by itself, so let's subtract this 4 out of here. And we'll subtract it on this side too. We're going to get that x is equal to negative 4 plus or minus the square root of 24. And there's only one thing I want to do. Whenever I have the square root of a number, I want to make sure it's simplified. Square roots should be simplified. So let's see. If I take this rad 24, I can break it down into 4 and 6. 4 is 2 squared, so we get 2 squared times 6. And the 2 can give up its square and come on out. So this is equal to 2 radical 6. So we're going to want that to be in our final answer. So x is really equal to 4 plus or minus 2 radical 6. Question 27. Isabel and Vicente are kayaking when they go over a small waterfall and the boat fills with water. Vicente could enter the water with a bucket in 40 minutes, while Isabella could do the same in 15 minutes. How long to the nearest minute will it take them to empty the boat together? So they're working together. So here's the setup. We've got Isabella plus Vicente equals total. Isabella can do 1 kayak over 15 minutes. Plus Vicente, who could do 1 kayak over 40 minutes. Together, they could do 1 kayak in X minutes, because I don't actually know how many minutes it would be. Now, if I take out the units, right? If I take out the units, this is a very nice, simple-looking equation. I'm going to want to get the same denominator on all of these, so let's see what that would be. 40, 80, 120, I think. So 120x is going to have to be my denominator, because 3 times 40 would be 120. 8 times 15 is 120. I could put a 120 here and a 120 here, and then I just need x's. So this is 120x, 120x, and 120x. Once that's true, and I've done the same thing top and bottom, I can cross out all the denominators. Here's my new equation. 8 times 1 times x, that's 8x. Plus 3 times 1 times x, so that's plus 3x. Equals 120 times 1, so equals 120. I get 11x equals 120. And they want me to round it to the nearest minute, so let me divide this by 11. Break out a calculator, because it's going to be decimals. 120 divided by 11, 10.9, which is 11 minutes. Okay, and that would be my final answer. We should always think, does this make sense? If Isabella could do it in 15 minutes, with a little bit of help, they could do it in 11. Yeah, that makes sense. 28 says fully factor. Factoring this is definitely going to be A times C. Right, these are A, B, and C. So A times C, 2 times 9 is 18. Now let's find factors of 18. So that could be 2 times 9 or 18 times 1. And they should be able to add to 9. Neither of these work. Let me think. Oh, 6 and 3. 6 and 3. So if I make these both negative, they'll add to negative 9. Perfect. So what we do is this. We split the middle term up into negative 6x minus 3x. I bring down the other terms with them. Now that I have 4 terms, I can use grouping. So group the first 2, group the second 2. 2 and 6, oh, those can both be divided by 2. And I can pull an x out from both of them. That leaves me with x minus 3. Here, I can pull out a negative 3, leaving me with x minus 3. I've got outside stuff, 2x minus 3. And I've got my inside stuff, x minus 3. And that is fully factored. I could always multiply with a box method if I wanted to check it to see what it's equal to, make sure it's equal to what I started with. 29, solve for the sum. What I want to do is get the same denominator, right? These need to have like denominators in order to be added. So here's what I want to do first. I want to factor this. So this can all be divided by 3. So I've got 3 x squared plus x minus 2. And 2 on top. This one's got to have a like denominator, so let's see. I'm going to be able to add these. Make a big fraction bar, so I got some space. This is 5 over 3x. So now here's what I'm missing. This is not over here, so x squared plus x minus 2. And I've got to put it on top first before I go into another move. It's got to be on top and bottom. And now the right side is missing an x. So if I want to put an x there, I've also got to put an x on top. Now they have the same denominator. So now they're the same denominator. I can smush them together. So I'm going to get 5 x squared plus x minus 2 plus 2x all over the same denominator, which is 3x x squared plus x minus 2. I always want to simplify, so what I'm going to do is I'm going to see if the numerator and the denominator can be factored at all before I just go calling it a day on this question. Let me distribute this 5 in, and let me also, I'm going to try to do A and M on that. Oh, I guess I could do A and M on the top as well, but I've got a like term up there. So yeah, I'm still going to distribute this, see what happens. So I add and multiply here, adds to 1, multiplies to negative 2. So negative 2 could be 2 and 1. Positive 2, negative 1. Yeah, that makes sense. So on top, I've got 5x squared plus 5x minus 2 plus 2x. Oh, that should be minus 10. Plus 2x all over. 3x. X plus 2. X minus 1. And I'm going to want to make sure that I combine these like terms on top, but nothing else is going to happen after that. So 5x squared plus 7x minus 10 all over 3x, x plus 2, x minus 1. Nothing crosses out or anything. This is going to be my final answer. As ugly as it looks, that's as simple as it's going to get. They are combined. We have added them. The goal has been met. 30. Find a solution or solutions to the following system. We're going to want to isolate, then substitute, and then we're going to want to solve. So let's isolate the y. Minus 2x minus 2x. I get that y equals negative 2x. This can be really helpful because y being equal to negative 2x, it can go in right there. So I'm going to rewrite this equation, x squared minus 13x equals 4y, but y gets replaced with negative 2x. So this tells me x squared minus 13x equals negative 8x. This is a quadratic, right? It's got an x squared, so I'm going to set it equal to 0. So add 8x to both sides. And it tells me x squared minus 5x equals 0. And these have a GCF, so I'm going to pull an x out from both of them. X minus 5 equals 0. My solutions are 5 and 0. So now here's the thing. That's what x is equal to. So I've got two solutions from that. X equals 0. And I've got x equals 5. I'm going to want to plug back into one of these equations. Specifically, this one seems easiest. If y equals negative 2x, y equals negative 2x, that should tell me what y is. So y is 0. And negative 2 times 5 is negative 10. So here are my points. 0, 0. That's one solution. And 5, negative 10. So there are 2 points of intersection between these functions because the top one is U-shaped and the bottom one is a line. So it hits at 2 points. That's what we've just solved for. Okay, identify all the roots of this function. So we're going to want to finish factoring it first. This becomes x plus 4, x minus 4. This can be factored out at a 3, leaving me with x squared plus 4. We set it all equal to 0 because that's what we do when we're finding the roots. And there are 3 or some roots. So I've got negative 4. I've got positive 4. The 3 doesn't matter. And what do I do with this? Well, if x squared plus 4 is equal to 0, let's solve for x. Minus 4 on both sides. I get x squared equals negative 4. And now I need to square root. Square root of x squared is x equals, don't forget the plus or minus, square root of a negative is I, square root of 4 is 2. Oh, but that looks messy. It should be 2i, not I2. X plus or minus 2i. Okay, next one. 32. Solve for theta. Alright, I'm going to want a calculator for this. The goal, of course, being that I get theta. So here's what I'm going to need to get rid of. I'm going to want a minus 1 to get rid of this. I'm going to want to divide by 2 to get rid of that. And then I'm going to want to arc sine to get rid of that. In that order. So that's exactly what I'm going to do on the right-hand side as well, because that's how equations stay balanced. Whatever you do on the right, you do on the left. So let me go to my calculator. I'm going to want to make sure I'm in degree mode. I am. Good. Now let's see what this is equal to. Negative 2 square root of 2 plus 2 divided by 2. Now that's just this. Now I'm going to do my 3 steps. Minus 1. I'm going to divide by 2. And then I'm going to use the second sign on that second answer. Second sign of that answer. Because I didn't want to retype that decimal, but you could. Negative 45. Okay. Question 33. Factor this, given that x plus 4 is a factor. Factors divide in evenly. That's the definition of a factor. They divide in evenly. So, them telling me it's a factor tells me to divide. So, I'm going to do this quick because division takes a while. So, x cubed plus x squared minus 22x minus 40. That's all going to be divided by x plus 4. Alright, that's x squared, x cubed plus 4x squared, subtract. 1 minus 4 is negative 3x squared minus 22x. X goes into negative 3x squared, negative 3x times. That gets me negative 3x squared minus 12x. Parentheses and subtract. That's going to get me negative 10x minus 40. X goes into negative 10x, negative 10 times. And that, when I distribute over, is going to get me negative 10x minus 40. And yep, it is indeed a factor. Now, here's what this means. This times this equals this. If I was to multiply these together, it would equal this. So factoring this is saying it's equal to x plus 4 times x squared minus 3x minus 10. That's equal to this. Now it's not done being factored. This looks like A and M. Negative 10 could be 5 and 2. Negative 5 positive 2. So this is x minus 5, x plus 2, and x plus 4 on the front. That is the fully factored version of x cubed plus x squared minus 22x minus 40. Next question, 34. Graph this. 4 cos 3 pi, 3 theta, not 3 pi, 3 theta, minus 1. So let's remind ourselves what this is. This is the amplitude. This right here is the midline. And this right here is the frequency. Now I told you guys that the best move for you to do here is to find period. The period is equal to 2 pi over the frequency. In this case, that means 2 pi over 3. Now I'll show you in a second what that means. 2 pi over 3 is the period. So let's graph this. My midline is negative 1. It go up 4, so let's think. 0, 1, 2, 3. 0, 1, 2, 3. Yep. And negative 2, negative 3, negative 4, negative 5. So I've used the midline and I've used the amplitude so far. The period is 2 pi over 3. That means that 2 pi over 3 is the end of where I get one full cycle. And that's a perfect graph. I've used the frequency through period, I've used the midline, and the amplitude. This is full credit. 35. Solve the following system of equations. Okay. Now, my goal is going to be to get rid of the same letter twice. So here's what I'm going to do. I'm going to take the first and the third equations at first. Negative 5x minus 2y minus 2z equals 6. And negative 5x plus 2y minus z equals negative 3. I'm going to add them up to cancel out the y's. When I cancel out the y's, I'm going to be negative 5 and negative 5 is negative 10x. Negative 2 and negative 1 is negative 3z. And 6 plus negative 3 is 3. Now that's a big move. Now y is gone. I'm going to want to do that again, but with a different set of equations. So here's my move. I'm going to distribute into this equation a 2. That gets me negative 4x minus 2y minus 10z equals 14. Now look at these two equations here. If I add them up, the y's will cancel out. So the y's are gone. Positive 2y, negative 2y. Negative 5 and negative 4x is negative 9x. Negative 1z and negative 10z is negative 11z. And negative 3 plus 14 is 11. Alright, so that's another big step there. I'm going to erase the scratch work. Here are my two equations. If I line these up, I can cancel out x or I can cancel out z. So that's exactly what I'm going to want to do. The only thing is they need to have the same number on the x or the same number on the z. So what I'm going to do is I'm going to write them in the right order first. Negative 9x minus 11z equals 11. And negative 10x minus 3z equals 3. I think what I'm going to do is this. Distribute negative 3 in here. Distribute that onto these. That'll get me 27x plus 33z equals negative 33. Then I'm going to take this and multiply it by 11. Distribute that in. Will get me negative 110x minus 33z equals 33. I'm going to add these up. The z's will cancel. 27 minus 110. I know it's not going to matter, but negative 83. Okay, so I get negative 83x is equal to, well, these cancel too, 0. Divide by negative 83, and I'm going to get that x equals 0. Okay, so that's my first letter. What I'm going to want to do now is I'm going to want to plug back into one of the middle equations. So one of these guys to find what z is. I'm going to use the red one. So negative 10x minus 3z equals 3. Well, that's just 0. So 0 minus 3z equals 3. That's just negative 3z equals 3. And when I divide by negative 3 on both sides, I'm going to get that z equals negative 1. Okay, so I got x, I've got z. All I need to do now is go up to the top, plug in and find y. And then I'm 100% done. So let's remind myself where I'm at. I've got that x is equal to 0 and z is equal to negative 1. I'm going to take this middle equation here. I'm going to try to find y. So negative 2x minus y minus 5z equals 7. This is 0, so forget about it. Negative y plus 5 equals 7. And a minus 5 on both sides. I get that negative y equals 2. I'm going to divide by negative 1. I'm going to get that y equals negative 2. So I'm going to want to state these in the right order. X, y, z. X, y, z. So that is the point where all three of these equations intersect. 36. Identify the equation of the parabola whose focus point is 5, 3, and whose directrix is a line y equals 1. Now, here's the idea. These are close to each other. They're both positive, right? This is positive y, and this is positive y. So I'm going to set this up. My points for here, for x1, x2, y2, y1, is going to be these 2 points, 5, 3, and xy. So x and 5, they're going to go here. Y and 3 are going to go here. So let me rewrite this. X minus 5 squared plus y minus 3 squared all underneath the square root is going to be equal to, since these are both positive, normally we would say that this is equal to y. That's like the default, okay? It's like the default. But since 3 and 1 are on the same side of the x-axis, they're both positive, positive, and positive, that means that they are closer. So how do you make a distance, which is this, closer? Well, we subtract from it. We subtract to it y minus this, y minus 1. Okay? This is still all underneath the square root. To get rid of it, I square both sides. And I end up with a box method, a box method, and a box method. Now I'm going to use a shortcut because the box method is way too long for what I'm about to do. X times x is x squared. Negative 5x times 2 is negative 10x. And negative 5 times negative 5 is positive 25. This is going to be y squared minus 6y plus 9 is equal to, and this is going to be y squared minus 2y plus 1. I'm going to want to cross out these y squareds by subtracting them on both sides. I want to move my y's in this direction, so I'm going to add 6y. And I want to get y by itself. That's the goal. So let me get rid of this 1 too. Minus 1 and minus 1. So let's keep track of what we got going on here, okay? This side is going to be 4y. This side is a little messy right now. So let me identify what my pieces are. I've got x squared minus 10x. I've got plus 25 plus 9, that's 34, minus 1 is 33. And that's all equal to 4y. In my last move, I want y to be by itself, so I'm going to divide by 4. And I'll divide by 4 on all the other terms as well. Simplifying them if I can. The correct way to write this is y equals 1 over 4 x squared minus 10 over 4, which is minus 5 over 2. X plus 33 over 4. Okay, and that would be the correct way to write the answer to that question. Question 37. The angle theta is equal to 240 degrees. Use a diagram to determine the exact value of cos theta and sin theta. Then use these values to find tan theta, secant theta, cosecant theta, and cotangent theta. This was the 6-point question on the midterm, right? So here's what we do. 240 degrees. What that tells us, 0, 90, 180, 270, 360. 240 is here. Drop a line. That makes this 60, because it's the difference between 240 and 180. That means this must be 30. And this is the right angle. Opposite the 30-degree angle is a 1/2. Opposite the 60-degree angle is a radical 3 over 2. These are both negative because this is left and this is down. This right here is cos, and this right here is sine. Now, I need to find tan theta, secant theta, cosecant, and cotangent. So, some of these are pretty easy. Tan is sine over cos, which is negative radical 3 over 2 over negative 1/2. I'm going to keep, change, and flip. Tangent's the only one that takes work, by the way. Every other one's pretty easy. So I'm going to keep the negative radical 3 over 2, change the multiplication, and flip it to 2 over negative 1. The negatives will cross out, the 2's will cross out, and radical 3 over 1 is just radical 3. So tangent is radical 3. Now all of the others are reciprocals, okay? So these are just flips. So what that means is that secant is just flipped cos. Secant is flipped cos. So 2 over negative 1, which is negative 2. Cosecant. Cosecant is flipped sine. So flip it 2 over negative radical 3, and there's no simplifying to be done. Last, cotangent. Cot is flipped tangent. So take radical 3 and let's flip it 1 over radical 3. And that's the solutions. Okay. I would want to rewrite them, of course, to be clear, but this video is getting very long, so let's continue. 38. Prove that this is an identity. So here's how we do it. We have a left-hand side, and we have a right-hand side. My right-hand side is cosecant squared theta. My left side is secant squared theta over secant squared theta minus 1. Here's what I'm going to want to do. I'm going to take secant squared theta. I'm going to change that into its cosines and sines. So this right here is going to become 1 over cosine squared theta all over secant squared theta minus 1. This right here is one of the identities, and these were from, if I recall correctly, lesson 61. Secant squared theta minus 1 is tangent squared theta, so I can make that substitution. I can, of course, rewrite tangent squared. Tangent squared is sine squared over cos, right? So this is equal to sine squared theta over cos squared theta. And now I'm going to keep this, change this, and flip this. So I'm going to keep 1 over cosine squared theta, change the multiplication, and flip this, cosine squared theta over sine squared theta. Once I have it like this, same thing top and bottom can cross out, and I'm going to get 1 over sine squared theta, which is, by definition, cosecant squared theta. That's what cosecant is. It's 1 over sine. And now the left-hand side is equal to the right-hand side, which was what we wanted. That's a full proof. Explain or demonstrate why 9 to the 3 halves is equal to 27. Well, so let's convert this, right? This means 9 underneath the square root with a cube on top, which is equal to 3 with a cube on top, because this is equal to 3. And then 3 times 3 times 3 is 27. I haven't explained, I've demonstrated. If I wanted to write it out in words, I could, but I've demonstrated. Solve for the value of x. So what I want to do here is I want to get the exponential term by itself, so it's minus 3 on both sides. I'm going to get that 16 is equal to x minus 9 to the 2/3 power. In order to get rid of a 2/3 power, I'm going to want to raise both sides to 3/2. Oop, 3 over 2. So these will cross out. If I do it on one side, I need to do it on the other. 16 to the 3/2. Now that's 16 underneath the square root to the 3rd power. So that's square root of 16 is 4, cubed is 64, is equal to x minus 9. And now all I need to do is plus 9, and x is going to be equal to 73. I could always plug back in and check this in the calculator to make sure I'm right, by the way. That'd work just fine. Last but not least, solve for the value of x. Wait, there's one more, right? Yes. Solve for the value of x. Once again, I'm going to want this by itself, so I'm going to add 3 to both sides. I'm going to get 4 to the 2x is equal to 24. I want to bring down the exponent, so I'm going to need to log both sides. Log will allow me to bring that down. Now it's in front and not up there, but I need to log the other side too. Got to be even. Now I've got 2x times log of 4 is equal to log of 24. I want to get the x by itself, so here's what I'm going to do. I'm going to divide off the log of 4. So I get 2x is equal to, this is a calculator question, so let's see. Log of 24 divided by log of 4. 2.29. 2.29. And let's divide by 2 to get the x all by itself. Divide by 2. And that's going to get me 1.145, which we can just call 1.15, depending on what the rounding rules are. Let's call it 2 decimal places. 1.15 is fine. All right. Last question. What is log 10 of 1,000 equal to, and why? Well, first off, log base 10 of 1,000 is equal to 3. Why? Because of the swoop. Because 10 to the 3rd is equal to 1,000. And that's it. There you have it. That's every answer from the review sheet. I hope that you find this incredibly helpful. I hope that you study and put in the time, and then we all score very high on the interim assessment number 3. See you in class.